Hey, and welcome to another video on how to start with Monogame. Today we're going to talk about animations. So, how do we incorporate animations into our engine? It's going to be kind of simple actually, or at least a simplistic approach, because we already have something called frame sprite that we have already created in previous episodes. Now, the first thing I want to do is upgrade our project a bit. We have this sprite called Tiny Male, and I made a new sprite. So I'm just going to go in and overwrite that one. So now we have a tiny male sprite here that has, I've opened it twice. I have 8 frames of walking towards us, 8 frames of going to the left, 8 frames to the right, 8 frames away from the camera. Now, the different animations will be these 8, and then another one will be this one, and a third one will be this row, and the fourth one will be the one walking away from us. And the way I'm thinking of doing this is quite a, like I said, simplistic approach. So we're going to write kind of our own pattern for how animations are interpreted. Now, we could actually start off by doing that just to show you how I'm thinking this will work. We'll create a new folder in the content, and we'll call it animations. And I'm going to copy a file because that's a bit quicker. We'll call it humanoid animation.txt, and if I go alt enter here, I can just tell it to be copy always. And let's look at it. So it's quite simplistic. So what it says is, first I'll have a name. I usually do these in JSON, by the way, but we'll keep it to simple files, and you can decide if you want to have fancier stuff like XML or JSON or whatever you fancy. So the first is a name of the animation that we call upon. We're going to say like, oh, this frame sprite should do this walk down 8 frame animation. And the next describes the animation. F will be to set a frame, like frame 0, set frame 0 on the sprite, and then wait 150 milliseconds. Then set frame 1 of the sprite, wait for 150 milliseconds, and so forth, until it goes to the end, and then if we want to, we'll have it repeat that or loop as long as we want to. So the way I've decided to do this in this project, and you can make it in many different ways, of course, but I'll have to choose one, and I've chosen to do it as an animation manager. So the animation manager's job will be to handle jobs, like animation jobs. We'll tell it to do this, do that, and it'll just handle all that stuff for us. We'll have to create a few classes to kind of work with animation a bit easier, and I'm thinking I'll do it like this. I've debated it inside my head. I don't know if I like this or not, but we're going with it. So we're going to create a folder in managers called animation, and this is where we'll put all the helper classes. Usually I would put them here in this file, animation manager, and I think that would be okay, but it kind of feels a bit sloppy. So hopefully this will make it a bit clearer when we add things to different managers, and we can easily find them. So first of all, I want to declare a few things, and I'll make a new class, and I'll have to check so I get my names right from the beginning. So let's start off with the animation token. So the animation token is going to be, oh, did I close that file? Not my intention. So this will be a token, this will be a token, this will be a token. So all these are different tokens in a kind of in a pattern, and we'll have to define what these are. Now I'll put it in the same namespace as the managers, so I don't have to also type the animation namespace. So what an animation token will be is it'll have an animation token type. We haven't created that one yet. We'll call it type. And it'll always have a value, a numeric value, at least the way we are creating these. So let's make this animation token type. We'll add class. Animation token type will be an enum. And we'll have two. One called setFrame and the other one called wait. We could call it frame because we're using F. This is just preference. I feel like F is a better short word for the, or short shortening to say frame 0, frame 1, but I do like being kind of explicit in how the token type is called, like it's set frame. We just don't say frame. Frame doesn't say too much. And you could argue, why don't you use S here? But S is more like stop or something. I don't know. We'll probably use S for something else. Okay. We're going to have something called animation state. So an animation will be in 3 different states. It can be running, it can be paused, and it can be stopped. We'll be using that soon, but we'll have this animation state. And now left are 2 classes. I'm going to create something that we call an animation job. So this is literally what we tell the manager. And I think I actually missed. Let's see. I didn't remember to take away the namespaces of those 2. So sorry, we'll get back to this animation job now. Okay. So an animation job will be what we tell the manager to actually handle. We're saying, you know, you have an animation job to handle here on this frame sprite, and we wanted to use this animation. We want it to be looping, or it's going to handle all the information about the animation in general. So I'll actually look at my notes previously here, because that'll help me speed this up a bit. So we'll have a frame sprite. We'll tell it to animate. A frame sprite, as we know, can be set with, like, you can set the frame of the sprite. So basically the manager will just tell the sprite what frame to use. And then we want animation tokens. We'll say tokens. And what's next? Animation state. We want that state we just created, so it's either running, paused, or stopped. And then comes some information regarding the actual, like how far we've gotten into the animation, in case it's paused or anything. So we'll have 2 values. One is current step, which one of these tokens it's on. Like this is the first, you know, 0th, 1, 2, 3, 4, and if we pause here, we want to know where we are. Like the current step is where we are in the animation. And then elapsed milliseconds in step. Basically, if we're in this step, how many milliseconds have passed of these, because we're going to update far faster than 150 milliseconds. Well, hopefully, if our game isn't extremely laggy. That'll be it. That's our animation job. Okay. Now, let us create a few variables. One will be a dictionary, because it being a string, and a few animation tokens, and we'll call these animations. This is literally to create a library of animations. Oh, diction. I can't spell that apparently today. And then we're going to have a list of jobs that it's currently running or needs to keep track of. And the int will be some sort of ID, so we can call these animation jobs by ID. It's going to be something kind of new in how that works here than how it usually worked. Since we're going to have an ID, I'm going to already create something called animation ID. And we'll be using that soon. So animation ID can start at 0. We'll say animations we'll instantiate these 2, so we don't forget that. And let's see, we need a few different methods here. One will be load content, and for every load content we usually need to talk to the content manager, because it's going to load the files for us. So we have this new content file humanoid animation. So we'll probably do something like p content manager get animation and say humanoid animation.txt. But we're missing one class that I want to create before we do that. And I believe I called it just animation. Just let me double check. It's good to have notes. Yes, we call it animation. And it's just gonna help us kind of. We can make it a struct. And we'll have a name, which is literally this name, walk down 8 frame, for example. And we'll have an animation token array, which we'll call tokens. This is basically, ooh, I hope I remembered. Yeah, I did take away the namespace, good. Yeah, so we kind of want to do this, and this is where we go. We'll have a few animations. Let's call it animation array, because I did call this one animations. So get animations. That's a good S there. Hasn't been created, so I press Control period, and it'll suggest to create this. Now I'll do public just because we usually do public. And we literally just want to read the file. So we could probably just take something similar like this, just to ease it up or make it a bit faster. Now, we will say, let's see here. We want to read every line from this stream. Let me just check one thing. I'll be right back. Okay, sorry about that. Yes, so where were we? Let's create a stream reader. And we'll pass the stream. And we'll say while reader end of stream is false. We'll say string line equals reader read line. So we'll read one line at a time, and we'll get a we'll divide them into parts. And let me just think here. Yeah. So with a line split, I will split it by. Whoops, missing my keys here. By comma. And we'll say string split options, remove empty entries, because we're not going to have any empty entries. And if we do, we just disregard them. Now, first of all, we're going to give an animation array in the end. So what I'll do is I'll make a list of animation, and we can call it animations here. And we'll have an animation. Actually, you know what? We'll just do animations. Add new animation. And we'll say name equals to. So that's always going to be the first part. Now you can do a lot of error checking here, but this is our data. So for now, we're going to assume that we know how to load our data and write it correctly. So I'm not going to add these 10 or 20 ways of checking whether the first value is correct, or what if you have an empty line. You get to decide those things yourself. This engine is more of a kind of get started with, not like the end all be all kind of engine that everyone should use, like scrap Unity, go use this engine. You know, it's a fun project. But definitely add any kind of checks you need to, especially if you let this be some sort of user input, like someone can create these animations and add them to a folder, and you should read them in and stuff like that. Anyway, so we should have tokens, but we don't have any tokens right now. Now this is where I get tested. I forget, there's some sort of way you can just skip the first one, and I believe that gives us everything else afterwards. Let's wait, what is it saying? Oh yeah, okay, so we'll have to, this is where link is probably not the, I don't know if it's really good for Monogame. I haven't researched that entirely. You can make these things, but you'll have to work around them a bit. But I'll show the kind of the easy way for now to do it. So we'll say new animation token. Oh yeah, and that is why actually we have, oh yeah, sorry. We have to do one more thing. That is what I'm kind of forgetting. We need to split up every token as well into two parts. So I think we'll wait with this. We'll just so it doesn't bother me with saying it's wrong. We'll do this for now. Okay, so we'll have to do for each string part in parts, and we'll skip the skip the first one. We'll say now I would like to call these parts as well, but I call them subparts then. So we'll split this one. No, actually, I won't. Sorry. We'll do call it token type equals to the part, let's see, substring 0 1. So we take the first, we're looking at each line by the way now, like and for now we're looping through these, and since it'll always be one letter currently as we're using it, oops, where did I go? Oh, I haven't, sorry, it's over here. There we go, content manager. So every first letter will be what tells us, like it tells us what kind of token type it's going to be. So it'll be F or something like that. The rest will be like the value, and we'll just say substring everything from index 1. So we just literally skip the first, which is the F or the W. The rest of that is an integer. Again, you'll have to do some error checking if this data could not be what you expect it to be, which is good practice to do, but we're not going to do it here. So we do want to have a list of animation token. We'll call it tokens. And we'll say tokens add a new animation token. And we'll say the type is, and then we'll just say token type equals F, then it's the set frame one, else it's actually just wait. Now you could do a lot of if statements and whatnot, but we only have 2. So we're doing the stuff we need to do in order to get this to work. It's either going to be F or W, but you could literally, in the way we code this, you could type Z here and it would have it as a wait command, because we're just literally saying if it's F, then do this. If it's anything else, just wait. This is an obvious kind of cop out for me. That's what we're doing. Else, you could do like create the token, token, and you'll do an empty one, and then you'll say, if the token type equals F, then you'll say token.token type, or type equals to set frame. Else, if it's W, maybe now when I've already written it, let's do it like this then. Maybe it is better. Sometimes, sometimes I just want to be lazy. But let's do it this way. So it looks a bit better. And then after that, we have to set the, by the way, then we don't have to do this. We'll just add the token when it's done. But we need to set the value, which is the number that comes afterwards. And now we're going to trust that the value can just be parsed. So we'll just say parse this value, directly in here. It'll of course throw an exception if it's not a number that is easily parsed. But we're going to trust ourselves that it is. Okay, so now we have a lot of tokens for this specific animation. We have the name, it's in the first value of the entire row. Now we're just gonna say tokens to array because it's a list. And it swallows it and it's all happy about that. Eventually we'll fill these animations and let's see where I shall put my return down here, return animations to array because it was also a list. Now get animations should just pick that file up and we actually have to say content animations humanoid animation.txt. Okay, and we have a bit of a way to go, so this will probably be a bit longer. Let's see. Let me just have a slight check on how far we are. About 20 minutes in. Okay, I'll try to make it an even 30 if I can. Okay, so we have now animations like in this animation array, and what I want to do is just literally for each animation in animation array. Whoops. You could do it fancier, but we're going to do it the less fancy way. You could do it with linking like to dictionary and stuff, but we're going to add it to the animation dictionary. So we'll say add, and the name is going to be the animation.name, and the animation array, or the animation token array, is going to be the tokens. So we read and we get like 4 of these animations that have names, and they have these lists or arrays of tokens like the frame sets and weights, and literally we just add them into our dictionary so that we have a bit of a dictionary. Why do we have this dictionary? I don't think I went through that, but if all our humans are, which likely in a game is going to be 8 frames based on walk that way or walk this way or walk that way or walk that way, you don't want to have like, or you might want to have, and if so you can create it like this, but this is like a library, like you can always call this walk down 8 frame. It kind of explains the exact same animation, so it is like one animation for all the different humanoids. Of course, if you want something like a speedier one, maybe you'll call one running down 8 frame, or you might want to have a 4 framed version or something, and you can just add them to this animation text file instead of having, you know, maybe a unique file for every entity. But if you want to have that, you know, you can add them like this as well, and you can add multiple files and load them into a dictionary if you want to. I hope you see the potential of that. Okay, so let us look a bit at what we have. We have done this, we have done that. Okay, so now we get to kind of the more fun part, where we're going to say play animation, and this is where we say what animation. Well, it's going to be this animation key, and the animation key is the name that we've given the animation. We could call it animation name actually. Let's do that. And we're going to say which frame sprite, and I believe currently that is, yes, that is it. Okay. And what we'll do right now is check if animations contains key, this animation name. So we check the library, do we have this animation? If so, we do this, and we'll create an animation job. And let's see. So first of all, the sprite we've provided, the tokens will be the animations p animation name. So we'll load it from the library. We just basically copy them over to this animation job. The state will be running, and current step is 0, and elapsed milliseconds in the step is 0. And now we have this animation ID that I created previously. So we'll basically tell the animation manager will say, okay, so we're gonna play a new animation. So I'm going to increase the animation ID because we're going to give that ID to this animation so we can reference it later. And this is just something I've done to kind of prove it. This is silly. I'm just gonna do it to kind of give you a taste of the silliness. But if this animation ID, since it's just increasing all the time and you just call a lot of animations constantly, eventually it might just go over the int max value. So if it ever just becomes the int max value, we'll just basically say animation ID is equals to 0. Like start over again from 0 so that it never goes over a max value. Now, this is where I might not have tried or tested things, but I'm not sure what the repercussions are. If you plus a max value, it might just actually go back to 0, or it might go back to like minus, like the min value might be minus, depending on if it's, yeah, actually it's, we could probably check that. The min value, yeah, it's minus. So I kind of wanted to start over at 0 again. But it would probably just lap around because I don't think you get the exceptions. Just something I would like to add. So we're going to add to jobs then, which is this one, an active job. So we'll say the animation ID. So it adds an animation ID. This is actually something you have to think about as well, since we add jobs with animation ID and this can loop around. Like, it probably doesn't remember animation ID 0 when it's gone through like that many animations to 21 billion or whatever it is, 21 million or something. So, but it could happen. So you might want to clean that up or make sure that this these animations have a lifetime that definitely dies or something. Might be a bit of a kind of a thing that you need to think about if you want. Oh yeah. Okay, so what I do here is also I just throw an exception. Animation doesn't exist. You could say, I guess, animation plus p animation name does not exist. Hopefully this will never happen because you will always hopefully call animations that always exist in your library that you have saved. Okay, so I think we just have 2 more. One is pause animation and it'll take an animation ID. And we'll have a stop animation, which will also take an animation ID. And because we're kind of running that low on time, I'm just going to actually, I think we can just copy paste this kind of easy code. Literally jobs, if it does have this animation ID, just load it up and change the animation state to paused. And the same goes kind of for stop. If it exists, then just call set the state to animation state stopped. Now we are missing the more important method, which is the update one. How are we on time? We're actually getting to that half an hour. This this part is actually kind of big. So I am considering to leave this one for last, or maybe we're actually done when we've done this one. You know what? Let's try to go through this one. Okay, so I'll have to kind of check the right side of my screen a bit more. So we'll check through all the jobs, because this is actually kind of a tricksy part with fixing the timings and stuff. Oh, and it's not an animation job. It's actually, you know what, we'll do a var, because it's gonna be a key. Oh, okay. You convinced me. I'll make the key value pair, and it's like an int and a animation job, right? So if job.value, no, actually, we'll say animation job. Animation is the job value. If the animation state is currently that it is running, we'll do this. Now we want to handle running or stopped. So we'll have an animation state is stopped. Because if it is paused, we actually don't do anything with the animation. We'll just kind of pretend it's not actually existing. In order to like remove things from our from this job, we'll have to have a separate list of animations to remove, and what we'll do here is we'll literally say animations to remove, add this job key, so the ID that we read in from jobs. So we basically just say this ID should be removed, and later here I'm kind of doing the cleanup stuff first, and we'll get into the more kind of complex stuff here. And in the end, we'll just go through this animations to remove, and we'll just say from the jobs ones, remove the one with this ID. So it's just kind of a cleanup thing. As soon as we get an animation state stopped, you could save them, but this is a way to make sure that the jobs, like that we keep the dictionary pretty small, and we only have animations in there that are running or paused. So pause them if you want to keep them in there or something like that. But you probably will stop them and replace it with a new animation. Okay, let's get to this one. I am going to, I think I'm going to try to make this, I was gonna copy paste a bit, but elapsed time in milliseconds equals to, and then we'll just check the animation elapsed. This is just to make it a bit clearer, and it's kind of needed in a sense. Animation current step and elapsed in, oh sorry, this is of course this is based on game time. The elapsed time milliseconds is how much game time that has elapsed in total milliseconds. Whoops, total milliseconds. So probably this is going to be 10 milliseconds. It's always going to be a very short or small number, so we'll just cast it to an int because that's what we're using here. It's a double, but I don't want to work with doubles, and it's not going to be that big. Like unless you're having a gigantic problem, it should still fit in an int. I believe it's elapsed in step, and we'll say animation dot elapsed milliseconds in step. Okay, so we'll do a do while, and we'll say do while elapsed time milliseconds is bigger than 0. So what we're going to say is, okay, so we have 16 milliseconds. When we call this update, it'll say, we'll pretend we have 10 milliseconds to work with. So we don't want to ever get stuck in like an infinite loop in any kind of way. So what I'm going to do is I'm going to deduct like a 1 millisecond every time I set a frame, because that's kind of, like it's sort of like cheating, because if we do this, we haven't waited 300 milliseconds, we'll have waited 302 milliseconds, but I'm kind of cutting it in order to kind of make sure that the elapsed time milliseconds always goes down as long as we're setting frames. Because if you just do an animation with like 10 setting frames, or make a loop that just makes them set frames, at least you won't have you won't have a loop that goes on forever here that we need to escape in some sort of way. So what we'll do is we'll check the animation, and we'll check the tokens, and we'll say the current step, that is our current token that we are on now at the moment. So we'll check the token type, and if it is set frame, we'll do one thing. Else, if it is token type wait, we'll have another handling. So if it is set frame, we'll literally just say animation, and we'll look at the sprite, and we'll say set frame, set current frame, and we'll set the value of the token. So in this case, the value is this one. So if we have a frame token and we get a value, we'll set this frame. And this is where elapsed time milliseconds will deduct 1 millisecond from the 16 that we have to work with in the loop, and we'll advance one step in our animation. So the next step will be perhaps this one, which is a wait command. So next time it runs this, we'll have 15 milliseconds left to spare, and we'll get to this part. And this part is actually where it gets slightly kind of more confusing. It doesn't necessarily have to be very confusing, but I'll first write it, and then we'll have to go through what it actually means, because it's kind of difficult, at least for me, to explain as I go. You know what? We'll copy paste this part. I don't know why I'm typing this if I'm not going to explain it as I write it anyway. So this is going to be the animation wait handling. So we'll have two different kind of approaches to this. Okay, so we have 15 milliseconds to spend in this specific token. Either we have less milliseconds than 150, or we're currently at like we have waited 50 milliseconds and we have still just only 16, which means it's still less than 150, so we should still wait. So we literally have the either we're still waiting because we haven't done this fully, or it's the other way around. Like now we all of a sudden have waited enough, so we need to go to the next one. Those are the two kind of ways, or the two kind of paths to take. So the first one is the token value, which is 150, to wait 150. If it is larger than however much time we've spent already in this step, which might be 0 if we just got to it, plus the total elapsed time that we have left, which would be like 15 milliseconds, then we'll basically just increase how much time we've spent in this step, and we'll say we've used all the time. Those 15 milliseconds, we've used all of them, so we set it to 0 so that we get out of this loop. We're done. We've waited in this step all these 15 milliseconds, and we're still not done, and we've recorded how much we've waited in this step. Next time it comes around, and perhaps the token value, 150, will be less than or met by the amount of time we waited in this step and the amount of time we have in this current update, 15 milliseconds perhaps. If so, we just increase the current step by 1, and we do a bit of math to make sure that we have whatever is left over. So if our elapsed time in this step plus the time that we have currently is say 100, we had waited 140 milliseconds, and now we add a 15 more, we'll have 155, which is 5 more. So we literally want to keep 5 milliseconds in the next step. To remember, we've already waited 5 milliseconds, by the way, in this next step, which will be this set frame one, and continue on. So we don't kind of because if it jumps like we want to be sure that it can handle multiple, like if we all of a sudden waited 700 milliseconds, we want it to jump in this loop, like all, 3 or 4 steps, because that's how much time we waited. So the animation will kind of be kind of time safe, so to speak. I hope you understand kind of the ways. Else you'll have to kind of think about this, try to think about this particular screen that we're looking at now, like pause it and think of it. But yeah, so we add current step plus plus because we've waited more time than we were allowed to, or an equal amount of time. So we get to the next step, and then we save the value into elapsed time milliseconds for the next step, and we say 0. We have 0. We have spent all the time, so we have 0 left, so we get out of this loop. Okay. And then we have this part, which is basically just if current step is more than or equals to the length of animation tokens, like all of them, then current step is equal to 0. So literally we constantly loop if we have reached the next step that doesn't exist in these animations. This is where you would probably like give the job, like you'll say boolean, like loop true or false, and if you want it to loop, it'll do this. If you set it to false, it'll instead go like, oh, instead of current step equals 0, you would say animation state is stopped, and it'll handle it here. Currently though, we have full animation on all the time. I think that actually, no, there's one more thing that I've not gone through, and after this while loop, we set the values. We've played around with these current steps and elapsed in step. Oops, and this is called something else now. We played around with these because we might have increased current step like 7 or 8 by now or something. In the end, we set it to the animation and how much elapsed in step we have, because we're waiting for the next update to go through all the animations again. I think that is it. Yeah, looks like it. Okay, so we still haven't done like the more important part. And I'll also add to that in my plans. I actually had something like an animation health check that would basically check that you have, more than like, or at least one wait token. And stuff like that. You can do that as well if you want to. Like when it reads in the animations, you could do some kind of check, like, do you at least have one wait token or something, and throw an error if you don't. Actually, we want one more kind of easy functionality, I believe, which is this one. Just a get state from the animation manager, like get state. And if it finds the animation ID, like which job it's doing, receive, get that state, else we return null, because it might be an animation that has run its course, and if so, we want just to get like a null. Now, this is gonna be the interesting part. We need to add this to our game screen. And which means we want an animation manager. Animation manager. Oops, I keep doing that one. Oops, and I keep doing that. Animation manager equals a new animation manager. You know what? I don't think this is how we do it here, is it? We could have it like this, I suppose. You know what? We'll do it like that. Sorry for fooling you there for a second. We'll stick to this pattern. It's good to be consistent. Animation manager. Also, did I not use that namespace? Okay, sorry. going back here to make a small little adjustment then. I'll take away this manager namespace from all these. I apparently haven't been using it in my previous ones, so let us not do that. So, a quick cleanup. There we go, everything is back on track. This one knows what this is now. Animation manager, get return animation manager, and here we want to, since it's a library of all the animations, this is quite okay to do. And we'll say animation manager. Whoops, I see I do the double. I keep shift held for too long there. And we'll send the content manager. And in the startup game screen, we don't need this. We shall let us see if I can use this correctly now. YouTube game instance animation manager. This feels like it could be shorter if we didn't do this YouTube game instance, but we only need one animation manager. And I'm going to copy paste this. Let's see, which one was the first one? Up. So we'll take the walk up 8 frame. That's the animation we'll call on. And we'll give it to the tiny male sprite. Which is currently not a frame sprite. And we'll have to change that because we now updated it to a framed sprite now that it has frames in it, which means we'll have to do a new frame sprite. Now this will require us to say how many frames X, like per how many columns. It's 8, and we have 4 rows, and it has no borders between all the frames. So that's the change we have to do in order to make the tiny male sprite into a framed sprite. We've covered that in a previous episode. If you want to check that, you'll have to go through the videos in this playlist. Okay, so now we just say basically play this animation, and this is kind of the awkward part right now in how this works. But we'll say tiny male animation because of how I've done it with the IDs. But so we'll say tiny male animation equals to this play animation. See, this is what I don't like about what I've already done, and I think we would refactor it a bit. Another thing you can do is, of course, like make this a bit shorter, and you'd have something like animation manager. I keep doing that, like this. So I think I'll do this so that we remember. I'm hopeless. I can't even not do it now. Actually, it's I think it's actually smarter to put that in the initialize. So it's a bit of a shorthand so we can see it all on screen. Literally something I'll do right now just to make it a bit easier. So we also want to say state equals to animation manager. It's not even fun anymore. I keep messing that up. Tiny male animation. So if it's 0 in the beginning and we don't have any, we don't have this animation, state will just be null. So we'll say if state has value, we'll literally just say state actually, let me just make sure I don't. Yeah. I am just checking. So I think this will work. If it doesn't, I'll have to pause. But yeah, then we'll just do animation manager stop animation. I will say oh, and the tiny male animation. So if there's already an animation running, let's just, you know, kill it. And we're going to copy paste this for all these, just to kind of get this to work in our. So walk down, walk left, walk right. Now something is probably wrong, or I've messed something up most likely. Let us hope it works on the first try, right? But I don't think so. I probably forgotten something. Apparently I have. Dang. Oh, and it was just one of these left. That doesn't count. Just so you know, that doesn't count. There needs to be some other error. Okay, so I'm gonna try to go to the right here. Oh wait. Okay, so it is not animating. That's not a big surprise, I believe, because I've forgotten one very important thing. So I know what I've done wrong, and I did forget something. So okay, I didn't get it on the first try. Let me first go to startup. I noticed that I have, when I press to the right, it's on is pressed. I want is held. Yeah, we aren't updating the animation manager, and we need to do that. So let's go to the YouTube game and update it with the game time so it can progress the actual animations. Now let's see if this works better. Okay, so it's doing something, and this is, yeah, it's resetting the animation every time I'm pressing right or left. I'll have to do a quick fix for that because time has run away a lot. Let me get back to you in a sec. Okay, so I'm back. I think I have to make a bit of a change here in order for this to work, and it's actually sadly like more time than I would like to put into this now when I've added a lot of time, but we'll do it just because I hope that people like long videos. So we'll add an enum called direction. Now I haven't pre-coded this, so we'll have to either win or fail as we do this. So these are going to be the different directions that the character can walk. Let's see if I can solve this pretty fast. So we're going to have a like eventually this will be in some sort of entity class or something, but for now we have a lot of different variables for just this tiny male person. But tiny male walking direction, and we'll have last tiny male walking direction. No wait, sorry, I only need the last tiny male walking direction. Okay, so in this update we will do direction tiny male walking direction equals to we'll have none, and we'll say in the end here is equals to animation tiny male and tiny, so used to saying animation right now. No, tiny male walking direction. There we go. So every update will determine which path or which direction he's walking. So we'll say tiny male walking direction equals direction up. And we'll copy this for all the different options. And we'll say when he's going down, it's direction down. When it's left, it's, you guessed it, left, and right. And I think we'll just take away all this other stuff I just wrote, because it won't work in this way. I kind of hadn't planned this far. My bad. And down here we'll say if tiny male walking direction is not the same as the last walking direction, we're going to do a switch on the tiny male walking direction, and we'll say if it is up, let's see, if it's up, down, left, right, or none. So in this case, we'll just say animation manager, stop animation, tiny male animation. We'll just stop whatever animation we have. In the other cases, we will have to, I'm just thinking here, we will have to stop the animation if there is one. So, which means we'll have to get the animation state. This is a bit of a roundabout way, but we only have one entity currently, so this is why we're doing this animation manager. Like, this is definitely not how your code should look in the end, because you would probably have this code in like an entity or something like it. Tiny male animation. So, if animation state, did I mess something up here? Oh yeah, sorry, I forgot the question mark to make it a nullable object. So if we have a state, and we could say and animation state. Actually, we don't care too much about what animation state it has. We'll just say animation I'm thinking here, that's why I'm a bit quiet. We're trying to solve things together here. See, I'm trying to stop the animation twice in this way. I don't think I need to, so you know, that means we don't actually have to have this. We can just be happy with doing animation manager play animation. This is where I should have kept the different animation names. I'll have to steal these. Tiny male sprite. And hopefully this will work better. If not, I think I'm giving up as a programmer. No, I'm not, but it'd be pretty embarrassing. Well, I don't expect it to work the first time around. Okay, so let us see if this works a bit better. It's quite good to have some sort of enum right now that keeps track of how we're walking anyway. Okay, so yes and no. Like, it's not stopping the animation. So that didn't work fully. It should have value. And if so, it stops the animation. Then we press it to the right. Oh, yeah. Oh. And we play this one. And not until we stop holding right. I'll have to check this off camera. Be right back. Okay, I'm back, and I think I was just a bit derpy. I realized I do not update this tiny mail animation, so it will never it will never work out, so I forgot about this part. When we play a new animation, we need to save this ID in the tiny mail animation. You know what, I also think that, just to be clear, this tiny mail animation should be named tiny mail animation ID, because it's an ID, so might be easier to kind of, because else you could think it's an actual animation, like the class animation. Okay, so let's see if this works better. I haven't tried it. Oh, it did work. See, this is something you have to think about if you like or not. He restarts the animation every time you stop, because it's playing the animation from the beginning again. This is something you could do with like play and pause and like work with that bit and have a bit of fun with that. But as you can see, it sort of works now. So yeah, I have already made this video extremely longer than I thought I would. I was hoping to do like a 15 minutes, but I think I'm like an hour or so in. I just hope that it's still kind of a learning experience both for you and for me to know how difficult it is to cram just something as simple as this into a tutorial. But if you liked what you see, just please put a rating down there or some comment if you like this series, because it kind of makes me want to do more if I notice that people actually want this. Thanks for the people who have already commented and said that they like the series. So all this stuff will be up on the typical site here on GitHub. I do upload every episode kind of to this YouTube game project, and I keep them in tags. So the next one will be episode 8, and it'll have a tag, and you'll just be able to download that if you want to kind of look at all the code here, or download it and fork it, or whatever you want to do. But it's up here on github.com. Anyway, thanks for being around, and I hope to see you in the next one, and take care. Have an awesome day.